AI and ML application on a single board based computer for renewable energy and EV technology by Professor Suman Deb, NIT Agartala. But before that, I am going to introduce a short biography of Professor Suman Deb. Dr. Suman Deb, serving as a head of CSE department of NIT Agartala, is also Associate Dean Academic and Chairman Institute Innovation Counseling and Startup. His primary research interest spans the area of visual intelligence with artificial intelligence, robot vision, human-computer interaction, and education technology. This is blended with critical issue of augmented face-to-face interaction. Innovation in teaching, learning method is a continuous endeavor of his work. He is also the faculty in charge of SCL and AI lab of NIT Agartala. He lead a vibrant research group named Visual Intelligence and Machine Learning at NIT Agartala. His team has developed various low-cost innovation in access control, humanoid robot, skeleton movement analysis, ROV and AGV path plan, SLAM visualization, etc. He is passionately involved in the design of computer-mediated learning environment for transforming traditional classroom with interactive scaffold. He has initiated artificial intelligence specialization under MTech curriculum and continuously as the faculty coordinator of the same. He is well known for his technical demonstration, prototyping, and motivation to large group of successful students. Apart from active academics, he is also better known as the designer of the both NIT Agartala and Triple IT Agartala logo. A person instrumental in achieving Guinness World Record accomplished with the most people folding original sculptures simultaneously is 895. His paper selected among top 3 during Indian International Service Festival at National Physical Laboratory, New Delhi. He has won more than 10 best papers during various prestigious international guided science model won first prize at state level science for multiple times. He has multiple design patent and developed various point-to-point robot and very low-cost ingenious Braille printer. He has authored more than 14 edited volume and book chapters with more than 90 research articles published in significant journal and conference proceeding. He had been involved in organizing more than 37 national FDP workshops, including 3 prestigious international conference, national level hackathon. He has also received various innovation and POC project funding, multiple research and consultancy grants that include prestigious DST, Imping Project Octa, a grant of 25 lakhs, MAIC grant accounting to 10 crores. Now I am requesting Suman Dev sir to start their talk, sir. Thank you.
Thank you so much. And it's an honor for me equally to be with you. First, please confirm, am I audible and my screen is visible?
Yes, sir. Yes, sir. You are audible.
Thank you so much.
And the screen is visible also.
Yeah, indeed, such type of FDPs are equally important for presenter and listener, because these are not only one-way listening, and even it's a electrical and electronics major FDP. And when I have seen the invitation given to me, I was feeling really challenging for myself, that how to present the components where I am working before a person who is expert into electrical and electronics. But rather, this such type of confusions are nowadays very less, because both hardware and software are going in a very tangible way, hand in hand. The title for selecting this talk, like configuring AI and ML applications on single board based computer, maybe it's not new to you all, but rarely we work into this topic as a practical application. So that's why I thought that the single board based computer may be one of the introductory thing for the audience, and application into renewable energy and EV technologies, maybe there is no direct hands-on for my personal experience that I have worked into EV, etc. No. But on the contrary, we have developed some robots where the same scale down matters are there the way an EV is there. Charging issues, then power monitoring system, and also the health monitoring system overall in regards to the power supply. So I hope the topic is very much in line with the FDP, and there will be no surprise for anyone that it will be completely a computer dominating part. I'm more focused into scalable computing systems which will be deployed in field. With that note, let us just outline the whole system. I will be definitely interacting with you, and I'll request that please give me some feedback so that it is helpful for me how we can tune the discussion. Rather than putting too much of theories, I try to accumulate as much as possible practical examples and practical experiences, and rather this will be a session of sharing my experiences with you. So as the outline goes like this, SBC testimony, that how these SBCs evolved, what can be the possibilities, and how they can be used as an edge computing, particularly for electrical and electronics engineering and applications. Now, artificial intelligence of thing, that is a very important topic which we are mostly working nowadays, and AIoT in our lab we are working for various machine vision related purpose, but that can be easily transformed into EV and renewable energy, mostly solar or wind, such type of any kind of renewable energy or any energy monitoring system. Finally, we will be having mutual discussion so that we can accumulate what we have learned from the matter. I personally feel, being a faculty of any domain, we always talk on a very specific expertise level. So when we talk about our expertise level, there is a very less mutual interaction where one can find out an evolving thought process. I am also having a role, Chairman Institute Innovation and Startup. So today when we are discussing multivariant persons are here in this FDP, we must find out the way how the applications can be connected and hardwares or other supporting systems can be exchanged as a problem and solution. So we follow a principle, by and large the whole thing is followed by almost all the institutions, that how an application or system can be innovative or novel. Definitely it follows three questions, that is it novel, does it solve meaningful problem, and does it create value. Today my discussion is also aligned with the same three things, that whether this discussion is novel, in novelty means in any kind of application or mutual connection to that, does it solve a meaningful problem and does it create value. Hopefully if we look into the geographical variant, right now I am at Agartala and you are at Rourkela or across country, or if not even across globe, due to these online facilities we are able to exchange the ideas. Now when the ideas are exchanged, the resources are variant. Here in our institution, some resources are available, there are some challenges. On the other side, you will not feel that is at all a challenge. So that's why such type of discussions are always geospatial information must be there before us. Now I'm saying it for few reasons. Geographically, whenever we are distributed with some challenging scenario, the natural resources are also distributed. Exactly, the consumption is also distributed. Now let me take a very specific example. Whenever we talk about driving or energy resources in hilly terrains, that is completely different from the coastal areas. And even the coastal areas opportunities become challenge for us, vice versa. So keeping that in mind, I just want to show the physical area where I am right now so that it gives you an apprehension. This is an aerial view of NIT Agartala. Now that is an alignment with the discussion of EV and renewable energy. Now if you look into the area, like any NITs or any institutions, they are primarily depending on large number of infrastructural resources, and second, they are coming up with any kind of disaster management. For example, if there are a sudden storm or everything is going on fine, we never think about the energy crisis or etc. So very frequently we face that challenge if there is sudden storm or for long time there are kind of natural some kind of calamities. Energy is the biggest problem comes to us. So in that regard, if renewable energy we are talking of, that is also having similar kind of natural challenges, maybe it for short time. Now in NIT Agartala campus, I am just taking as a sample that we require a commute inside the campus, we require some kind of commute. Now that commute is not required very heavy horsepower, it can be run by a small e-rickshaw type thing. But the problem is who will drive that e-rickshaw? We can put some person who will be working for wages. But you think there are some seasons like summer vacation, etc., what that person will be doing. So we are now gradually thinking of an autonomous e-rickshaw or autonomous e-vehicle. But the challenge and opportunities both I am discussing at the beginning, that it is not a very big research component, but it is an application challenge. If we go by research, many cases the research it not be a publishable research, it may not be too much of discussion research, but see that practical problem, as I said, a commute, maybe in many NITs we require some kind of commute which will be working periodically, but those matters come with some operational issues. So today my main topic of discussion is single board based computer. I'm sure many of you have worked or heard about this. If not, I'll go thoroughly about this SBCs. Actually, SBCs were initiated for school level programming, and it's a single board. By that you can understand the processor, micro memory, input, output, all are embedded in a small card, that means credit card size machine. There are different brands, different kinds of manufacturer are there nowadays, and it's not just confined to one particular brand. Mostly these SBCs, this is a complete computer. It's a you can say micro computer, and this micro computer is having fully operating system support, all kinds of IO support, and all related things what you can do with your laptop, desktop, or any kind of small scale computers. Now the purpose of SBC, I'll definitely take the feedback from you just after seconds or 2-3 slides, that what is your idea about SBC before I go into the system, because you must have an idea about the SBC application or SBC's existence in market. If we see, these particular systems are having a system on chip. So kind of architecture in such a manner, this is a bit old architecture, even present architectures are much more agile, but till it's a fundamental architecture. I have also referred it, where this system on chip gives you very less maintenance, and definitely it is having limited power. But our maximum intention is now to utilize those limited computation system with scale down computational architecture in software level. So this is a chip, single chip, and this is a schematic diagram. So by and large, this particular construction is supported by a small computer which is requiring less power, 5-volt power, and that 5-volt power which you can operate by a power bank. Now the question is, what is the purpose of all those things? You are aware that most of our even car, bike, they are now having microcontroller equipped injection system. So many cases you have seen that MPFI engine, multi-point fuel injection, those type of controllings are done by some embedded chip, but now these are programmable. So whenever you are next time visiting for servicing of your car, you will be observing that they are putting a computer and they are calibrating everything just by an UI. So programmable hardwares are much more easier for us to control and use. Now primarily, if I'm sure the faculty members are definitely expert into this domain, there are various scholars, but you can think of in electrical engineering, if your system is dominated by logical controls or UI or software control system, it is always convenient, which is even in practical, that people are now using software controlled hardwares. That means any kind of substation or any kind of control panels are coming up with some interfaces. Now the question is different here. Why an SBC is discussed? It is considered to be an edge device. That means a system which is a full-fledged computer which will be in field, and it can communicate to a high level computer or high powerful computers as a base station with a communication medium. Now if I see the variants of SBCs, this is an actual view. I have just some of these boards are available in our lab, and some I have just taken for reference. Though as I mentioned, there are large variety of manufacturer, but everywhere the basic architecture is same. I have just shown in earlier slide. So all those SBCs has primarily the basic architecture of a computer, and they are having an onboard operating system. Mostly we load Linux operating system, various variant of Linux you can load. So this is the first level idea how one SBC look like. Now in this case, these SBCs, what are the advantages they are giving you? Definitely they are 24/7 working machine. you can deploy them for a large scale of controlling or for long time processing. Second advantage, the size is small. Third advantage, if you look from hardware level, there is no moving part, all solid state memories or chip level systems. So the maintenance part also becomes very less. And finally, which is very important, cost. The cost is very less. Even nowadays, the 8 GB RAM configuration and configurable like Intel Atom like processor or Celeron like processor, such type of things are also coming in a range of 10 to 12,000 rupees. So you can observe that you have a computational resource first. Now we can move slowly. What are the things we can do on this SBC? So as I am from computer science, not looking too much detail into electronic circuitry and hardware, just looking after what are the facilities provided by this hardware as a layer of application. Now if you blindly take this chip and load it your desired operating system, then comes the next matter, how you are going to communicate. Definitely USB options are there and GPIO options are also there. For this communication to the hardwares or peripherals, general architecture, and for any kind of other network communication, Bluetooth is inbuilt, network wireless network is also inbuilt, or you can use LAN or wired network. So that was a primary introduction from use of layman's idea. That means I am having a computer which can be used for some of the observational purpose, control purpose, etc. Now, there are a lot of other variants. I am just mentioning here Raspberry Pi, Banana Pi, then different other variants are there. They are completely different from microcontroller based system. Remember that microcontroller based systems, when we make electronically erasable programmable memories, and these are having not onboard operating system. But in case of such type of SBCs, you have a full operating system. That means an application developed in your laptop or desktop running system, you can easily scale them down and convert to those SBCs. So I will discuss about this scaling them and what are the challenges of AI and ML slowly. Now more and more these type of discussions are important for us because there is an innovation coming up that can you make your edge devices intelligent. Just for example, you are having solar panel and there is a grid of solar panel. Definitely there can be a chip, you can just design your electronic circuit which will be observing with simple if else logic, and very specific logic is embedded into some circuit and you can put there. Now think it in on the other way, can you make it intelligent? The moment the term comes intelligent, that means we want to do human like some kind of calibration, behavior, actuation, etc. So the question comes, whenever there are that means solar panels or photovoltaic panels, they require some kind of adaptation to the sunlight or the voltage that is power they are generating or the requirement of the power. So you can easily program them and you can change geographically distributed system. So one system developed at Gujarat may not be same performing at Assam, Agartala or any other place. So based on the geospatial location, we can make them more agile towards the programming control. So that is the intention for which I am just sharing this with you. Maybe you are the expert and you can find out how much it is applicable and how much it is important to you. Now its working criteria and working other style, it is exactly like one PC. Once you connect it, you will not realize that you are working with such a small system as operating system is there. So that is the advocacy, that once the operating system is there, you don't have to bother too much about the controlling or the language system or programming system, where it is not a fixed one. You can use multiple languages, you can use multiple applications. Now programming language, as we are working in our lab with various languages, C, C++, Java, Scratch, Ruby, Python, almost all the things whatever required. Largely we work on Python based systems, where we can find out the problems are scaled down. That means a large program can be scaled down for such type of small systems. I am skipping those slides quickly because these are only saying about the abilities and different kinds of configuration matters. Now, as I told you, many cases when I discuss with students or different scholar group, they have a large confusion. Sometimes they, without understanding, they sometimes make a confusion that yes, we work with Arduino or such type of microcontroller based systems. but there is a gross difference. We always work with some kind of modifiable interface or some kind of control interface. Now Arduino is a microcontroller which can be worked in association with the SBCs. So that's why I'm keeping side by side. There should not be any kind of confusion between the microcontroller based system and SBC system. SBC is a full-fledged computer and Arduino is a microcontroller. What are the definition description? Already it is known to you and there is nothing from my side to discuss unless I get some feedback. Now there is a range of microcontrollers. I'll show you some of the application. As I told that I'll share some experience only how we have evolved over time of using SBCs and microcontrollers for multiple applications. Now this range of boards, if already you are aware, fine. If not, it's first time you are seeing, you can observe here the size and shape and the application wise these microcontroller boards are changing. So almost all possible microcontroller boards from the Arduino family I just try to kept here. It's because whenever we go for any controlling system, definitely we require interface and these Arduinos are working as interface to the SBCs. So various wearable systems starting from say 1 inch or 2 inch size to larger size, all such boards are available. Even few years back, 10-15 years back, these type of boards were not available so easily in market. That time many cases we used to take separate microcontroller burning system and we used to assemble them in breadboard or some kind of boards. But that time it was very difficult for us to make accessible system. Now these are readily available, you can pick them, just properly interface and you can control any hardware or any external device. A range of sensor. I just thought to share with you all these three phases, that is SBC as a computer, microcontroller boards as an interface and sensors definitely as a part set. So variety of sensors readily available in market which are starting from voltage sensors, optical sensors, different kinds of you can say resistivity, lot of sensors are available. Nowadays you search a sensor, it's available. So all those sensors are your primary component or percept to take data, because unless we make a proper sensing mechanism, whether it is a photovoltaic system, whether it is an EV battery or whether it is a power health monitoring system, nothing is possible to control. Even you can take multivariate parameters and you can group wise accept them, large number of parameters as much as you want, only proper interfacing required. So I hope my intention is very clear to you. That means computation, control and sensing. Now it comes about the actuation or decision. So here just I try to discuss that mostly we discuss about AI and ML. Even though I personally feel if I talk about artificial intelligence, it is covering the machine learning system also inside it. Separately, no need to say about machine learning as a different domain or different segment. But you know, as applications are specific to some kind of machine learning system, so the subset even taken as a full component. Here just for a discussion, I try to share how neural network can be used using this type of microcontroller based system or sensing system. I just try to use here an example only. So in our lab, we made different kinds of assemblies, like a small example that there are some plants, indoor plants. Can we make a neural network systems which will be used to sprinkle water onto them? Now ideally, if you use a moisture sensor, you can read the moisture level, whether it is a soil moisture or environment moisture, both you can read. And based on that, you can take the rules that when the sprinkler should be on and off. It can be a very simple rule-based system. The question comes, if it is a rule-based system, then why the need of any kind of neural network or machine learning forcefully to add complexity? But the answer is very simple. When you are using here a plant whose requirement is different and you are changing the plant, next day you are placing another plant, the system will not understand. The system will sprinkle every day the same amount of water without considering the type of the plant. So that type of things are important for us to understand, that why artificial intelligence or such kind of pattern or human-like behavior is important to incorporate. So this is one simple example which we can take for understanding. I am not giving this example just to make a very elaborated problem. It is just a simple problem to make the scenario understanding. Now, computation is actual strength. That is the main takeaway. Even if you are from electrical engineering, for your case also, it is control and computation, and highly electronic systems we are working. That means this low voltage or circuitry system. But the logic development is important part. Whether that computational system is low cost and supporting to our different monitoring system. I tried to gather some of the working that whether at all SBCs are important for renewable energy and electrical engineering system. And before coming, it was not my experience that SBCs are in electrical or EV system. But when I just try to find out large number of that means research is going on. There are some reference with the hyperlink I have given. So you people can also visit and find out that large number of solar and wind power along with EV systems are based on SBC, and they are working with SBCs. So this is not a surprising matter, just suddenly I have selected this SBC topic. So these are some significant papers I found. You visit and see the detail of works. Now, whenever we are talking about SBCs, it becomes more of an intelligent control, more of an calibratable control, more of an changeable control. And the machine can talk to another machine. The machine can even talk to a server station. The machine can even talk to a common cloud knowledge base. That means, as I started today with geographical description and some challenges, the similar part can be done by a same set of machine, but in different output or behavioral level. I hope the point is very clear. Now, this particular example I am showing from the idea of edge computing. As all you know, edge computing means whenever, let's take it in a very layman's language. Previously what we used to do, that we used to take environmental information. Environment doesn't mean that only the air, water, soil, etc. Environments, any working place where a machine or a human or a system is working. So this environment comprising of even network, power system, even the working conditions. So whenever we talk about getting data from some kind of devices, we feel that is only sensing. But nowadays the device itself, sensor, have a little bit of intelligence. They can take edge level some decision. Definitely when the decisions are taken, it can also send the data to some cloud for a higher level of analysis and decision. It goes on starting from drone, now all the EVs, and even most of the car now have a connectivity. That means the service station can have a monitoring of all the cars data. If some costly car, if you see, their maintenance is always monitored. And high-end car like Mercedes, BMW, none of the car is now not without any network system. They are constantly monitored and they are observed that whether there is a malfunction, any kind of discomfort, serviceability, everything is monitored. So these things is coming that your final device which is in the field, they are having a little bit of intelligence, and those data are constantly coming to a cloud system where the data can be taken up as a decision support system or taking a larger level perspective. Now, if we see the domain of power system, now domain of power system, it's maybe new to me, but you people are dealing every day with those things. Recently, I had visited one hydropower station, and it was a surprise to me that large big machines, they are working, and generally we always work in a small computers. Any computer science people, they are working largely with a small window, keyboard, mouse, that much. But whenever any in true level large scale machines, for example hydropower system or coal power system, there are a lot of sensor based decisions are there, and even one decision is made wrong, it may be catastrophic. These are not new to us, but the innovation today, as I started, what innovations we are thinking of, can the power system people say that we require a large scale of array of sensors, or the climatic condition what is happening here, it required to be given a feedback to another climatic condition where they can find out the relation or correlation. So such type of systems are important. Nowadays energy metering system, recently at Agartala we have seen the large installation of air conditioners. Now large installation of air conditioners people are buying and they are installing. But finally what happens, this substation or zone wise there is a large load in peak hours. Yes, it is already known, you have a system for that, but can the data distributed way can be collected, which zone is having large power consumption? Maybe there, may not be there. But the question is coming, in my locality I have not seen that the power consumption systems in a runtime they are collecting. Maybe the energy meter reading, every month people are coming, they are giving the data and then they can analyze, but it is not a runtime analysis. I hope we can take up such type of thought that such SBCs can be installed in zone wise, where it will be monitoring the local power system distribution and local power load, and they can communicate to a base station. Now why this proposal is possible? Because they are low cost. Previously it could be very high cost, now they may be completed by a single unit 20,000, 25,000 like that. Now the question comes, what is the information here important? Information is not here only load, here information is not sudden surge in power system. There are a lot of management issues come. Now those management issues are propagating from edge to the final control system. So these SBCs may be loaded with human logic and SBCs may be loaded with challenging factors. So for example, the challenging factor, fault management, fault detection. So all those things can be monitored. I hope this could be an extended part of use of SBC. So I just mentioned here which is already adapted and taken up from the larger group of electrical engineering. But as I mentioned, application wise, can the scholars and group of faculty work into such type of small installation of predictive maintenance, then predictive load. So all those things may be very interesting one. Now summary of these machine learning techniques in terms of power system application. Now, as today time is very constrained, I have not gone through the detail of machine learning, assuming that you people aware about the machine learning primary classifications. So that's why I just named here what are the different categories of machine learning systems. It may be a shortcoming from my side. Now I am feeling that I could have included here some more slides about the classification or different kinds of machine learning primary techniques. Anyway, the category of the supervised learning, which I'll give some of the examples for all of our convenience, like renewable energy forecasting. It's a very challenging term, renewable energy forecasting. I don't know what are the system we are having right now. All of you can participate, or we can just, can anyone participate in discussion? Hello? Okay, I will request the admin, is it possible that the audience can unmute them for a few minutes, because otherwise it feels so one-way discussion.
Yes, sir, it is possible. We are allowing them to.
Perfect, perfect. So first of all, let's have a break of 2 minutes and have a discussion first. Large participants are there, around 89 participants. So I'll request your volunteering discussion. Otherwise, I may be in one way thinking and your requirement is in other way. So please, one person give me a response. Is this SBC known to you, or these SBCs were priorly you have used? Any one person. Please unmute and have a discussion.
Participants, kindly, take a note of that. All of you are unmuted for this session. So you can just take the note of that. You can unmute yourself and you are allowed already. Okay, only video is turned off. So at the end, we will enable that one too. Kindly respond to the call of the speaker, please.
Sir, we know it's SBC, but we are not used it for these renewable systems.
Okay. See, I'm just happy that one person has responded and assuming that is a point of concern. So, considering that my computational and programming experience says that whenever exact problems are required to be solved, we don't have a linkage. Just the example I have given you, that few days back when I visited in Arunachal Pradesh one small hydropower system in Jong, it was largely a manual system. Maybe there are very high tech, but it was a very long installation and all the machineries were manual. And when I was coming out, I found a big truck came which is completely new machine which is supposed to be installed there. So I was thinking that there are a lot of electrical engineers and they have no option to make it monitored or make it some kind of such type of SBC or any computation system. So why not the electrical engineering students can visit and find out an intelligent monitoring system or control system. Control may be very hard, but at least monitoring system we can do. So I hope this SBC could be a one point of application for you all. Now moving back to the next question. As I mentioned, that renewable energy forecasting. Renewable energy forecasting, anyone can tell me what is this particular renewable energy we understand? What is renewable energy forecasting? Anyone? Just have a bare discussion. Renewable energy forecasting.
Prediction of solar power.
Yeah, largely, exactly. And you know, a prediction of solar power, it will be more interesting if we can give a good example. For example, there are solar systems installed in one institution or in one building facility. And if it is completely dependent on the solar system, there is a large requirement of environmental prediction. Because if it is predicted next 4 days there will be cloudy and there will be rains or there will be fog, you can understand the management of power is disrupted. So for that you require a proper correlation between the energy already you have stored and the energy required in upcoming days, for which you require very proper calculation of the system. Any one of you have experience in working into such type of system? Anyone? Theoretically it sounds very good, na? Theoretically all of us have read so many papers, theoretically we have gone through many such type of challenging things, but see, it is possible for us to work into this domain collectively by electrical people, electronics people and computer people. But see, the point what I have raised, this is a very vital point. But for us, we have multiple connection of our service line electricity, and if solar power is there, so we don't have that challenge of management. But even then, the challenge is required. But this type of forecasting is very, very important for renewable energy. Otherwise, renewable energy may run out in your daily basis services. Next, power system stability analysis. Yes, that is also very important. Now, this power system stability analysis mostly hard coded. Load forecasting, fault diagnosis, how much is possible? I just try to put here some vital point. Now, non-intrusive load monitoring. I have no idea about non-intrusive load monitoring. Anyone can tell me non-intrusive load monitoring? So these terms all are very important research topic. Anyone? Please highlight non-intrusive load monitoring. If I am audible, I will request you, yes, try to give the response. Otherwise, I'll assume, okay, we are all equally unaware of the term. Okay. Do you know intrusive load monitoring? Okay. Do you know load monitoring? Definitely yes. Now, why there are two terms? Intrusive and non-intrusive. Okay. I'll come to this point slowly, because there are a lot of terms. I thought that as I am from computer science, it may not be known to you, but as it is a subjective matter to the electrical people, they must know the thing. Now, power equipment fault diagnosis, electricity market forecasting, theft detection, false data injection, power system, quality, lot of this. Everywhere it is under the category of supervised learning. Now, as you know, supervised learning, the name itself suggests that any kind of learning you can say in a layman's language, if you remember one go or state condition and take it as a feedback, so that next time you can calibrate the system towards your goal. And it comes with a very simple equation. If you have a efficiency or E, which is the difference between goal and outcome, and you always try to make the efficiency as much as possible close to 0. But in terms of just I am saying in a computational terminology, not efficiency, it's a error term, rather it's better error term E. Error term E will be a difference between goal and output. So efficiency will be definitely proportional. Now you can find out if I make all the data fit to a machine and take a pattern, okay, this is the pattern, or machine can learn the pattern, whether it is a spatial data or some kind of temporal data, it can be always taking a pattern out of the usage, and then the system can work as a human mimicking behavior. But in case of unsupervised learning, same we can go with renewable energy data generation and analysis, where we don't know how the pattern will be created. So we take the data every time, and over the year, whatever data collected, we can take a decision. So the same systems can be taken up as both supervised and unsupervised learning for power system applications. Just I have kept here some of the domains. I hope all of you can go back and search your computational logic and computational system for these specific domains. So reinforcement learning, so this categorization will give you a lot of helpful insight that how you can take your different power system related components in computational domain, highly dominant by edge computing or such type of SBCs. Now coming to a kind of description, that's why a machine learning system is separated from application point, unsupervised, supervised and reinforced, which is again classified into regression and classification. Now problem wise we make all those things usable and applicable. So whenever you see that simply taking up a problem and classifying it to a problem 1, problem 2, problem 3 without labeling them, it is also one way. Or another way may be there are some labels. You are only putting those problems into appropriate labels. So these names are labels. It is up to you in which category you are taking the problem and solving them. As I told that my works and my all systems are aligned towards more application. And we have a private limited company started by my student, and I'm a mentor, that is Subo Bots Private Limited Company. We develop robots, small scale indoor robots, and those robots, just I want to show you some of the citation of the work. These robots are not toys. These robots are having very serious equipments, for example, depth sensors, lidars. But you know the biggest challenge of all those robots, the power. We are using some batteries, chargers, but not having a depth knowledge into that. And we created a programming logic of health monitoring. Now for our case, what is the health monitoring? It starts with the supply voltage, it starts with the heating issues, and all parameters are taken together, and we make them a component called health monitoring components. Now these robot, whenever it moves, it is having lot of issues. The major issue comes, these issues comes first of all, that whenever we charge the system and estimate, it will run for 5 minutes or it will run for 10 minutes. Now whenever exactly it is running for 2 minutes. That means where the fault is coming, we require the help of electrical, or we require the help of electronics engineering. Even though these robots are working, and just example I have given 2 minutes, 3 minutes is not correct. Actually these robots can work for 8 hours, 9 hours continuously. But when a system is working for 8 hours and 9 hours from the base station, we have to monitor what is that means reduction in power. That means if it is moving in such a place from where the reverse power is not available, then it will stack up into a remote location. So my point is here, you know, every time, so this is a small display you can check. It's a complete health monitoring system, it's power. So that this is the point of discussion with you today, that these robots are working on health, and which health is considered to be power. Power communication system. My control logic has nothing to be related with health issues. They are working with logic. So all those things definitely require some kind of computation. We are using inside this machine, the SBC is there, which is looking after the control, which is looking after the logic, and also it is looking after a specific destination. It is not a blind search machine. It's an intelligent search machine where it is looking for particular goal and also looking around the surroundings, that what are the objects in surrounding, and what are the maneuverable path. So all those things are observed. So I think my point is very clear. If you talk about EVs, EVs are also having the same challenges. Maybe their battery is a few hundred times larger, maybe their power challenges are few hundred times larger. But you see the same management and prediction system on the console of EV is there. That is, what is the predicted mileage you will be getting. This is another robot, and you know, this particular robot is a Rangoli robot. It's a large size which can make a very large size Rangoli, and its power issue is much more challenging. It is having onboard that means control system, then onboard wheeling system, and we initially try with onboard batteries, but when the batteries we keep, it becomes very heavy. So see, indirectly it is coming up as a challenging part for us for movement. So we have to supply wired power system to this particular robot as it requires to run for hours long. So again the power system required to be calculated, monitored, and all those things anyway just not related to our discussion. I am just showing the output, large scale output. This is another robot. It is also very power hungry. Now in this particular robot we require a conversion from DC to AC. That's a very interesting fact. When I was developing this particular robot, we used a full scale motherboard. That means a desktop motherboard and the Intel i7 processor. And we tried to find out a conventional motherboard system if requires a DC power system. Just take my example. Whatever the motherboard you are having in your CPU, you take it out and try to run it with DC power system. You will find out the motherboard power supply SMPS is exactly converting AC to 12 volt DC and different distribution. But can you run it directly from battery? Very difficult. We found the solution costing around 40-50,000. So what was the easy solution? I have taken a simple DC to AC converter adapter, and inside this there are two batteries and made the conversion. But while this conversion, the efficiency got very down. So I am sure you could understand my problem. That means we have taken the full scale motherboard which was difficult to run on DC. So inside this there was SMPS, fully SMPS, there was an DC to AC conversion, and then computation. So finally the efficiency of this robot was very less because it's power hungry, heating issues, and then we moved to SBCs. Presently our architecture is like that. We have different kinds of visual observation, object detection, decision making, etc. And all those observations are largely taken up by the SBCs. When the SBC is not able to take up for any decision, it sends it to the base station, which is a powerful computer, but it takes longer communication time. So it takes a decision and send it back to again to the SBCs, and system works very nice way. Now this is a simple architecture. If you can see, there are field sensor and field actuator. They are connected to the edge system, which is our SBC, and there is a communication module. It is sometimes line of sight 2.4 gigahertz normal wireless communication just for sending some very digit data, or sometimes you are using LAN, that means wireless LAN system, and it can talk to the primary base station for larger processing. And in this way we have developed several systems like this particular for an agricultural application. Just I was making some load test that whether it will be able to take 40 liters, 50 liters of pesticide onto it. Very less computation onto these devices, but they are very intelligent. They can take decision of their own, and these are some of the examples. These examples may not be related to energy system, may not be related to any other. On this particular example, you can see the girl is holding a device which is Nintendo Wiimote. We have reprogrammed it just to make a human computer interaction system where the movement of, yeah, anyone wants to say?
Yes, madam. Good morning.
Excuse me? Okay.
Yes, madam.
Next.
Madam, already I informed to your technical expert. Can you arrange second time of
This is the problem of unmuting everyone.
some doubts are there, madam. That's why.
Sir, the mics have been disabled, so
okay,
please.
Fine. Perfect. So as my intention was today to discuss with you the applications and possible challenges, may not be always directly leading to very deep research, but for application wise we are lagging largely. This is a small glimpse of our lab. This lab we are taking some hands on experiment and hands on problems which can be solved and that can be connected to our research, or that can be side by side go on with the research. My point here is very clear. That means as from computer science I am working, my challenges are the simple matters of interfacing, observing, efficiency, etc. Similarly from your side you have a big problem, but there is a communication gap, that is why you are not able to deploy the monitoring and control properly. This particular example, you know, we are just taking, we have taken a simple snaps from a film, and we have fed to the machine learning system to identify whenever a car is moving, then the monitoring system will be observing besides the driver what are the other situation in road, like what are the road sign, what are the other vehicles, whether the driver is violating any kind of traffic rules, and that will be observed by those SBCs. Because on the running car I cannot put a very costly laptop, or even if you put a laptop, the laptop is not that much of agile that year after year or month after month you can put it in the car, because there will be vibration and etc. The laptop will be getting that means it will be having some kind of mechanical problem or physical problem very easily, whereas these SBCs can be embedded into nicely for a long time. One of our another major area is simultaneous localization and mapping. Now this is coming up from an application surround situation or awareness about the surrounding. This is a three-dimensional depth view. That means the computer can see all the surroundings like such type of dots. This is very important even for EVs. EV has multiple aspects. One is definitely the power source, second is control source, and third, nowadays around the world people are working that can the vehicle be intelligent, can the vehicle see what is around it, can the vehicle move by itself, or can the vehicle assist the driver whether any kind of mistake is happening. So such type of simultaneous localization, mapping and depth sensing is even a cross engineering application, like civil engineering application to estimate the internal structure of a building. Even whenever the robots are moving, they look around in such a manner, a three-dimensional figure. Our robots, they can estimate what is around them and what are the size of the room, what are the obstacles, what are the maneuvering path, and how they can be used. You just imagine one of the viable application, elderly care. If you are having a lone person or even one young person alone at home, if the person is facing some emergency, such type of moving devices can observe whether the person has fallen, whether the person has required some kind of accidental support system. So all those things can be added more and more by different kinds of indoor application. I personally just advocate these movements and just try to show you. I have not gone technical detail into those. Let's just look into this particular device. It is primarily a mechanical challenge. This is a triangular, it's called a holonomic drive. Can you observe it's a triangle? Now why the triangle shape is there? In various places we can apply geometric movements. This is a very agile robot, and its payload capacity is around 30 kilo. You can put 30 kilo load into that, and fully handmade and iron structure. Inside this we have a fully computational system, we have a depth sensing system. Even civil engineering people, if there is any participant from civil, they can understand ground penetrating robot, you can ground penetrating radar you can deploy, and you can also scan the floor. So various applications can be there. I don't know whether there will be any direct application for electrical engineering, but you see we are dependent on electrical systems. And electronics, definitely there is a 90-10 ratio, 90% electronics and 10% computer only. Because I always say these hardwares are tangible systems. These tangible hardwares require a very strong support of power, communication, and then logic. Now logic is working only when you have a proper dimensional system, you have a proper physical system. So this is, I am just really happy that I can share with you that my challenges and my problem. Definitely some of you of this group are interested we'll communicate, and together we can make some kind of very interesting works. Now, all those works require a combination of multiple domains. This machine learning part, AI part, power system parts of one of them. This part is my strength and where I work. This is called visual inference of surrounding. You can see on the screen, may not be so much clear, there are some dots available on the screen, and dots have created. This is called a cloud representation of surrounding. And then we process what are the depth vision, what are the components. These are not just like a clear vision of camera, because the clear vision two-dimensional images give you less information. You require the depth, quality of those images are not here measured in terms of resolution. Quality of the images are here by the cloud points, and then we process and find out. Anyway, I just try to stick to those applications too much. This is a movement mechanism. Here, you know, as I am working on only 12-volt battery, there are 4 stepper motors are working, and these stepper motors require constant large power system. And whenever we try to make them a very agile power system, we failed. We failed only because that I have a limited knowledge into this area of power quality and etc., which is normal. So that's why I invite, and I feel very happy that I can be with large number of people of electrical engineering and electronics, where people can find out the challenges of application. That means even today you want to start an application, you require first a courage. Yes, we are going to make it. It's not so easy to develop a system suddenly. You require a lot of supportive dependencies, and then only it is possible. I personally can say that cutting of metal is again a problem of mechanical engineering, but unless the frame is ready, where the computer science people will work, where the electronics people will work. So that's why nowadays these FDPs are really thought provoking. These FDPs are much more even into, because you know this 1.5 hour is not sufficient to teach you some theories. If required, you can separately sit with to learn the theories, but these thought provoking systems are very important. This is the website of my research group. We work on particularly visual intelligence. Now this visual intelligence comes with electrical, electronics, different departments. So I'll request you all, if you are interested, you can talk to the organizer, Tanmoy and others, and definitely we can come up with a challenging problem and challenging solution in a collaborative way. How much we are distributed, that largely matters, but we can definitely come up. Even though time is given from 10 to 9 to 11, but I have a very urgent meeting scheduled at 10:30. So I try to skip almost 50% of my slide and try to come up with this only innovation discussion. I'll be very happy if we can have a discussion right now, and on that discussion, if anything comes down, we can move back and discuss with that matter in large scale. So I request cordially to all the participants, let's have a discussion. And on the topic of discussion, I can go in a specific way. Please, next 10-15 minutes, we can have a detailed discussion on any of the required matters. Even you can give me feedback that what are the problems I have discussed, whether it is at all interesting, whether it is having any kind of value addition. If you want to criticize some matters, yes, it is also possible. So have a very open discussion. That is the importance of any kind of such type of assembly. Please.
Dear participants, you can be able to unmute yourself and speak up right now. Hello, am I audible? So
Yes,
participants are requested to unmute yourself and you can speak up with the speaker. So kindly just have a look into your queries and please speak up. And at the same time, I'll be turning on the camera also at the end of this session. After this Q&A, we will have a group photograph. So over to you all participants. Listen.
Just to change your mood, both of us have moved to some very greenery areas. But anyway, yes, sometimes whenever we want to discuss, we really feel short of words. I have shown those robots and etc. You just try to understand the difficulty I have faced in my construction, and when I was developing it, and then finally moving to a private limited company. That means encouraging my students to be into a private limited company. You know, I know in this whole group you are a very top researcher, you are doing very good works, but try to understand, in our country, most of the cases, if we want to go for a solution, we find that after 2 or 3 problem solved, third or fourth things we get failed. For my case, you see, today I have shared the power is a major problem, battery is a major problem, and if we can make this, it becomes a very interesting robots. You search on Google, and find out how many such manufacturers are available in our country. It's not because people are not capable here, very much capable, but the capable people and exact application people, there is a gap. Like in power system, if you have a collaboration with computer science people, I'm sure there will be a very interesting output will come up. And in case of my all the designs, if you have seen these robots, there is a heating issue, very much problem with those heating issues. We solved them very you can say interesting way, because we tried to converge all the problems into as much as possible smaller units, and now with the application of SBC we are able to capable run them in a very nice manner, in the most effective way. Anyways, I'm just trying to make the lighter mood and encourage all the participants. Just give any feedback, anything you are coming to your mind, anything. You want to go back to some of the slides? I'm here 15 minutes. Same thing happens in our classroom.
As the participants are not speaking up, so on behalf of the participants, I would like to share my own experience being the electrical engineer. There is a phobia for all the electrical engineers how to start up with AI and ML, because all of them are very much interested, and you can see the footfall of the largest number of audiences over here. Only they are being captured by the name of this short-term course. That I very understand about it. But while working, it comes with from where to start. That is a very common question I believe all the participants are facing a lot. So if you will be highlighting on this, it would be helpful, I believe. I don't know whether it is common question for all or not, but this is a question from my side.
Definitely that question is very important, and deliberately I told few minutes back that this 1.5 hour is not sufficient to give you a tutorial that how the AML applications are done, because the thematic matter is to get your problem. So in electrical engineering, you define a problem which required to be solved. That is the first matter. Then you find out the computational challenges is not that you will be solving everything. You try to find, just for my case, do you appreciate me if I start reading these all electrical matters and start doing, but without electrical engineering, none of the computer applications are solvable. So let's take it in a courageous way, that first you identify a proper problem with all parameters, that these are the parameters, these are my problem, and this is possible solution. Now discuss with any of the person who has already worked with AI ML systems and try to make whether the feasibility of the problem is there. Third, rarely it will be a chance that you require to go through all the AI ML techniques of yourself. Yes, eventually when you will be working with your colleague of computer science or some part, otherwise the fear factor is very genuine, because even if I teach you right now ML or matters, it will be half knowledge, because you have not studied automata, you have not studied algorithm, you have not studied operating system. Suddenly someone is teaching you ML, it makes no sense. In many cases I found even my computer science student and other branch students, they sometimes come and say, I have started ML. I said, how it is possible when fundamentals matter you have missed out, suddenly jumping to ML. ML you can do, but your fundamentals matters also required. So exactly the, hello, am I audible?
Yes, yes, sir.
Yes, sir.
Hello.
Yes, sir. You are audible,
Yes,
sir.
sir.
Can you please confirm?
Yeah.
Hello.
Hello.
There is
You're audible, sir.
Okay.
Probably
Suddenly the picture got stuck, so I was okay. So please. So what Professor Tanmay has raised, this is a very vital point and equally important for everyone. So please take a note. You identify a problem. Don't just jump for in general AI ML matters. A valid problem, a possible solution, and then find out how it can be mapped to AI or ML matters.
Okay, sir. Thank you very much for being with us. I hope I'm audible to you. हैंड रेस को बंद कैसे करें? बंद नहीं हो रहा। तो अच्छा। Hello, sir. Can you hear me, sir?
Hello, am I audible?
Yeah. There was some disruption in between. So now you are audible, sir.
Hello.
Yes. Hello.
Can you hear me?
Yes, we can.
Oh, I don't know, something happened in my end.
No problem, sir. That's a common issue in online.
Hello, 1, 2, 3, check. It's fine.
Yeah. Can you hear me, sir? Any other audience
can you hear me?
Yes, sir.
Can you hear me?
I can hear.
Okay.
I can hear.
Hello. Okay. Sorry,
Yes,
there's a
sir.
disruption.
Yeah.
Okay, what Professor Tanmay has raised, that's a very vital issue. I will request that don't jump anyone to start learning ML from the beginning. You first design a proper problem, try to understand how the problem required to be solved by ML techniques, because there are a lot of heuristic techniques also. Sometimes people forcefully put only ML or AI techniques nowadays, it has been observed. So just try to understand a proper problem, and solution makes you the understanding of ML very nicely. Then you go on subsequently knowing the matters. And another interesting part, that programming should not be done from halfway around. Programming should be done some fundamentals, then you go for the logic, and then go for the languages. Many cases you start working on instantly programming syntax and semantics, but the fundamental matters must be there. Today whatever SBCs I have shown you, these are so interesting that if you can properly assemble them, a complete system will come up. If you just look properly, any of the car dashboard, every dashboard now having a digital display. At the back there are small SBCs, and definitely those SBCs are calibratable. Just below the steering there is a plug, you can plug it and you can connect your interface with any laptop. You can see the interface is programmable. That means you can calibrate the system from your computer. And yeah, please, any other thing.
If any query from the audience call, or otherwise you can connect with Professor Suman Deb through email that has been already shared with you. As said, he has an urgent meeting, so we will be just winding up the session at this moment. Before ending this session, I'd like to thank Professor Suman Deb, Assistant Professor and HoD of Department of Electrical Engineering, NIT Agartala, for sharing your experience with all the audiences and the grassroots works that you are doing. Fortunately, I was one of the students of Sir, and during our days, it was the infant stage of our institute, and obviously we could not be able to see a lot of things of Sir's expertise. But apart from all those activities, I could be, very gladly share with you all that Sir is multi-talented. I mean, not only in the aspect of AI and ML, he is a very good artist also in different aspects. So that has already been shared with the biography that he is the designer of the logos of NIT Agartala as well as IIIT. And apart from other things, he is also a very good interior decorator. So these are the good things, and a multi-talented person in front of us, and very dynamic. So whatever I have seen him before 20 years, he is exactly like the same as of now. So at this point of time, I'll be requesting all the participants to turn on your camera so that we can be able to show us to our speaker with a memorable way. So I'll be requesting you kindly to stop your sharing so we can be able to capture the whole screen with all the participants.
Yeah, Tanmoy, if you permit, just before I conclude, I have another request to all the participants. You have seen that we have developed few robots. I was expecting that some of the feedbacks I'll be getting from you. You know why I'm again and again requesting for the feedback. There is always a point of criticism which makes a development very interesting. If I get any time in future fortunate to show you physically those things, I invite you. You can come, or sometimes I will try to come to you. These robots are solving any kind of problem domain matters. For example, there are 3 robots, 3 different problems. One is a Rangoli maker. You can find out Rangoli maker robots. It's very interesting, and these Rangolis are, none of them are just kind of raster drawing. They are all vector and generative vector. That means AI is there, ML is there. Now we are working on a situation. You give a situation and it will create a story of that Rangoli. जैसे आपको कैसा पसंद है, किस तरह का चीजें आपको चाहिए, ओकेशन कौन सा है, then it will be generative rangoli. So this robot is coming up with a different touch. Another robot is coming, mehendi maker. Now you put your hand into this and it will make mehendi onto that. So this is also a visual challenge, and I'll share in some other occasion, because rarely there is a cross section between electrical and computer. Now as Tanmoy has just mentioned about the artwork, so that's why I'm saying the problem is important. Once we come to the solution, it will be definitely mutual discussion and the problem may be discussed and solved. So I'll request that maybe it is not possible for you to give any positive or negative feedback at this moment, but I'll be very happy if you can just tell me whether I'm doing right or wrong, but at least give your feedback to those offline matters also. I'll be very happy and will be thankful to you. Thank you once again that you have just invited and given a scope to discuss the problems. May not be up to your expectation of AIML, any kind of coaching or teaching class. In offline, if you want, I'll be very happy to share any kind of AIML detailed discussion with you, irrespective of any kind of problem domain. Thank you so much. We can proceed to the next.
Sir, I'd like to share with you. We have a open feedback system. I mean, the participants are filling the feedback of each of the sessions. So I'll be very happy to share the feedback once I'll receive from them.
Thank you so much.
So thank you very much. I hope my volunteers can confirm whether the photograph has been captured or not. Okay. Thank you very much. Thank you, sir. So participants, we will be turning up for our next session at 11:15. So we will be having 1 hour gap in between. Thank you very much.
Thank you, sir.
Have a good day and everyone stay well. Thank you. Bye.
Thank you, sir.
Bye.
Thank you, sir. Thank you. Thank you.